Alright guys, I decided not to give you written instructions for this lab, mainly because I didn't want to write it down. So I'm just going to give you the instructions here. What you need to do today is after, I assume you're done with your quiz by now, but you're going to be looking at the relationship between the force that is placed on this object, because we know that once it reaches equilibrium, it will be the spring force pulling up will be equal to the force of gravity. So ultimately we're looking for the spring force, which just so happens to be equal to the force of gravity, how that relates to the distance that the spring is stretched from equilibrium. So right now the spring is at equilibrium, it's not stretched or compressed. So before you get started, you want to make sure, you'll just take this and squeeze it here. Once you squeeze it, you can move this ruler up and down, but you want to make sure that your equilibrium position lines up with 0 centimeters. Okay, so I've already told you the purpose. This is what you need to do today. You need to make sure you have purpose, procedure, data, and analysis. Your purpose is to determine the relationship between the spring force, found by the force of gravity, how that relates to the distance stretched. Okay, so for your data, you're going to take different size masses. These are, just laying around the front 2 tables more than likely, and just get you a couple. I will say, don't do more than 300 grams, and don't be a turd and overstretch this, okay? Once it stretches too much, it's permanently deformed, and then I can't use it anymore. So please, please, please don't do that. These 50 grams work fine for each data point. It doesn't matter if you use the same data point each time. Oh, no. Sorry for that. I thought that you couldn't hear me. I thought my microphone was turned off and then I was going to be upset, but it wasn't. So anyways, you have everything set up to begin with. You're going to take your mass, put it here, okay. See how far it stretches. So it looks like this mass, which is 50 grams, stretches it to about, let's see, I'm going to get that as still as possible. It's going to oscillate no matter what, but it's about 1.7 centimeters. Now, I would record that in my data table. Your data table needs to look like this. So you're going to do 5 trials, okay? Now, you need to record the mass that you're hanging there. Record that in kilograms, okay? The way you get your mass in kilograms is to divide the number of grams by 1,000. Okay, and then you need to record the force. Well, the force is the force of gravity. How do you get the force of gravity from a mass? You multiply by 9.8. Okay, so once you know the mass, you can, you can find the force, and when of course you're measuring the distance. Now, your distance, which is delta x, must be in meters. So to get from centimeters to meters, make sure you divide by 100 and record that value. Okay, so, my first trial, I'm going to add 50 grams, 0.05 kilograms, then I would multiply that by 10 to get 0.5 newtons, and the distance is 1.7 centimeters. Divide that by 100, that's 0.017 meters, okay? Then you're going to change the mass. I'm going to change the mass by adding another 50 grams. So now the total mass here is 100 grams. That's 0.1 kilograms. That's 1 newton. Okay, 1 newton stretches it out even farther. I'm going to record that distance from equilibrium again. I wouldn't say the distance from 1.7. I would say the distance from 0. So you're measuring the distance from equilibrium each time. Once you're done collecting your data, you have all of your data here, you're going to go into Excel on your computer and graph force on your y-axis. Okay, so even though it's the first column here, okay, in your data table, you need to put it in the second column in Excel. So in Excel, you actually need to type the delta X column, and then you need to type the force column, because I want delta X on the X axis and I want force on the Y axis. Okay, there's no specific reason other than it will make sense when we talk Monday. So once you have it graphed in Excel, I want you to obviously take a snapshot, screenshot, snippet, use the snipping tool, whatever, and put that in your document for your analysis. So by the end of tomorrow, completed, you should have your purpose typed, your procedure typed, your data table typed in a Word document, and your analysis. That's where you do the graphs in Excel and then copy your graphs onto your Word document. Okay, remember, I want force on the y-axis, delta X on the x-axis. I also want a trend line. Okay, you've done this before. You've used Excel to graph, so I trust that you can do this. If you can't, out of the 11 of you, one person in the classroom should be able to figure out how to do a trend line, and to where I can get the equation, because I definitely want the equation. Okay, in your analysis, make sure you put the trend line with the equation. The equation will be very important Monday. Okay, anything else? Anything else? I don't think so. I think you are good to go. I hope you have a good weekend. See you Monday. Hope this isn't too bad. It's definitely not busy work, so have a good day. If I can find this stupid off button, I'll end this video. Come on. Oh, gosh. Oh, there it is. Alright. Bye, guys.